Hello friends, let's see what is real-time system. Now what do you mean by the word real-time? Real-time means when it is working against the real clock or it is giving output in specific predefined frame or in specific frame of time. Let's see what do you mean by what real-time systems. Now real-time systems means the systems which are measured against the physical clock or the real clock. Now let's an example. If I'm using or if I'm doing any task, I am doing with respect to my clock. Now clock means the one which is in our hand or which is a GPS clock where the whole world is working against that. Now why it is important in embedded system? In embedded system, the clock says how the system is performing against or with respect to the time. So embedded system, a real-time system, when it gives the output in the predefined time frame or task, means it will give its services when the predefined time is over. The deadline shouldn't be missed. In other words, it will tell that it should meet the deadlines. Now take an example of missile guidance system. Now in case of missile guidance system, if that launching and the target hitting is not at the perfect time, then what will happen? The missile may hit the wrong target or it may fall at some other place which can be disastrous for the human being or that particular area. Now what are the applications of real-time system? Chemical process and control chemical plants, automated car assembly plants, cellular systems, multi-point fuel injection systems, aircraft guidance systems, missile guidance systems, nuclear plant control, railway reservation, supervisory control and data acquisition, that is SCADA, and video conferencing, that is multimedia transmission and reception. Now let's see example of car assembly. Now in car assembly there are sequence of robots which are working. In car assembly point, when the car body comes, it has to be fitted with screws, it has to be welded, the seat covering, all type of different jobs are to be done. Now suppose if one task is over and if the car is not moved to the next target and robot keeps its arm down, which may damage the body of the car. So that shouldn't happen. Means that when the car body comes, then robot should start its work, and once the job is over, the robot should move back and the car should move further. In this way, the complete car assembly system works, where sequence of robots are completing the task or the services in the given time frame. Another example is SCADA. Now where the SCADAs are used? They are used in chemical plants or many other things. Now in this, there are different things which are working when one point as an input is given to the another, from that output is given to another. Now if the sequence is not properly maintained, then there might be a mishandling and then chemical system may be disastrous. Another example what you can take is a bottling plant. In bottling plant also, from one stage to another the time is fixed. In other words, if I'm taking any embedded system, that timing should be very perfect, it should be strict. Next example is multi-point fuel injection system. This is in the car. Now why this is used? So that fuel can come from the different points and the injection of the fuel and the consumption of the fuel should be such that it should save the fuel. Now if timings are not proper or the combustion is not proper, then what will happen? The fuel may be more or it may not give a perfect output to the car and the car may not work properly. Now let's see characteristics of real-time system. The first characteristic is simple and single purpose. Next, small in size. Next, inexpensively mass produced. Next, specific timing requirements. Next, reliability. Next, performance. So these are the characteristics of a real-time system. Let's see the characteristics one by one. Now simple and single purpose. So real-time operating system or the real-time systems are designed for single purpose only. Now take an example of missile guidance system which I've already given you. In that what will happen? The missile guidance system will only guide the missile. It cannot launch the aircraft. So its work is dedicated and fixed. So it doesn't serve various applications within a single platform. Now example, again another example is washing machine. Now what is the function of washing machine? It has to dry the clothes. So drying, spinning, rinsing, it should be done in specific amount of time. Take another example, that is microwave oven. Now in microwave oven, when I have to cook the food, I have to set the time. So within that time frame only it will cook. If it works for more time, the food may get damaged, and if it for less time, it may remain un. The next is small in size. Now many real-time systems exist in environment where physical size is limited. Now take an example of wristwatch or a microwave oven. They are smaller in size as compared to the general purpose computer. Now since they are smaller in size, they require less CPU power and less amount of memory. So the PC, if I take an example, it may have a 32-bit or 64-bit processor, but a real-time system may have 8 or 16-bit processor depending upon the application and the speed at which the application should work. Similarly, PCs might have several gigabytes of memory. The data which is being processed in real-time systems are small in amount, so huge memory is not needed, but a small amount of memories which is there in kilobytes or megabytes are needed. The next is inexpensive, mass produced. Now this embedded systems, since they are used by many people or in huge amount, the production cost should be very less. Now take an example of washing machine, microwave ovens, digital cameras or wristwatches. All this should be at low cost so that more and more people can use. So they should be inexpensive. The next is specific timing requirement. Now in specific timing requirement, I've already told you the real-time system should be very critical in meeting the deadlines, or they should be very strict in meeting the deadline. That is, the response should be guaranteed within the specific time or the constraint of time. Real-time operating system should be considered by the timing requirement by using scheduling algorithms. Now, if in a case of real-time system, if many processes comes together, then the system should properly schedule those processes, and scheduling those processes will give the perfect time output in the perfect predefined time frame. Basically, real-time systems are characteristics by correctness that involves both correctness and timelines of the logical input. As I've told you, if there are multiple inputs coming, which is to be taken first, which is to be taken next. So there should be priority, there should be proper scheduling, and it will give you the proper output. The next point is reliability. Now reliability means, when I take an example of any embedded system, many of the times these embedded systems are working without any operator. Working without operator means it will start its process until end of the process. There shouldn't be any intervention of operator unless and until the system gets blocked or held up somewhere. So there should be very reliable. The real-time system provides the reliability that ensures produce a result a given time or choose a profitable activity for the current location. Then comes performance. Definitely the performance should be nice, or it is a key factor for any real-time system, and the performance will be when it meets the deadlines properly. Different types of real-time system. So real-time systems are of two types. One is called as hard real-time system, and second is soft real-time system. As the word says, hard and soft. Hard means they should be very critical or very strict with the timings, and soft means they can be little flexible. In other words, hard real-time systems are not flexible, whereas soft real-time systems are flexible systems. So we'll see what is hard real-time system. So as I've told you, hard real-time systems means they are not at all flexible with the timing. Means the process which are given at the input should meet the deadlines and the timing constraints. Missing the deadlines are disastrous in case of hard real-time system. The usefulness of the result produced by hard real-time system decreases abruptly or may become negative if the deadlines are missed. In case of hard real-time systems, if deadlines are missed, then the performance will be very drastically falling down of any embedded system. Now take an example again of missile guidance system. If it is repeatedly missing with the deadlines, then those missiles will be damaged or they will be lost, and it can be economical as well as human life loss. Another examples of hard real-time systems are nuclear power plants, flight controls, air traffic controls, and vehicle subsystem controls. Take an example of vehicle where multiple subsystems are functioning, starting from your turning on till the process of moving. If any subsystem fails, then what will happen? Car won't move. Same is the example with air traffic control. Now in air traffic control, a missing deadline with milliseconds or microseconds can also be a disastrous, because it is controlling the air flights which are in air. Nuclear power plant, in that case, if you're missing the deadlines, it can be disastrous because it may lead to a destructive output. Even same is with a flight controls. Next is soft real-time systems. Now, as I've told you, these soft real-time systems are that not critical with time. They are soft or flexible with time or the time constraints. So missing the deadlines is acceptable. If there is something delay, it is acceptable, but that shouldn't be always missing the deadline. Missing the deadlines cannot be that disastrous as in compared to hard real-time system. Usefulness of a result produced by soft real-time system may decrease gradually and may be negative if the deadline missing is increased. Now, in case of soft real-time system, if there are multiple processes coming, if one process is delayed, then second will be delayed, then third will be delayed, then fourth will be delayed, and what will happen at last? The complete system will go in the negative time of the deadline. In the sense, its performance will go on decreasing gradually, not like that of in case of hard real-time systems. Let's see the examples of soft real-time system. Railway reservation system, cellular systems, telephone switching, video conferencing system, online databases, and e-commerce websites. Now, if you see all these examples, they are working one or other way with respect to computer. Now, in this case, if any of the deadline is missed, it won't create any disastrous output. Take an example of cellular system. When I dial a call, if my call is not connected at perfect time, it won't make any difference. Maybe a delay or 1 or 2 seconds or 3 seconds or 5 seconds is acceptable. Similarly is with video conferencing. As we are seeing in video conferencing, if your video is delayed, it doesn't make any difference, because once it is delayed, after that it will continue in the same flow. You might have experienced that. Coming with railway reservation system, when you start doing the reservation, if your network is delayed, the reservation may be 1 or 2 minutes ahead or later, so it won't give any output. So in other words, the soft real-time systems are not that critical with time. They are very flexible. Let's see an example of hard real-time system. Now, the anti-braking system. Now, if a car is without anti-braking system, what will happen? When car is moving and somebody applies a brake, what will happen? Generally, brakes are applied at the back or the front, not all four together. So what will happen? When the brakes are applied, few wheels may get stopped and few wheels may be moving. So what will happen? The car may get skid or it will start moving at the same point. Now, if the same system is with anti-braking system, then anti-braking system, there is some control principles. Now what they do, when the brakes are applied, they are applied slowly and gradually to all the wheels. So all at the stretch will be applied with brake, and car process or the car movement will be slowed down gradually. So it won't have that skidding effect. That is what is the difference between a car without anti-braking system and car with anti-braking system. Same is the role of gyroscope. Now, in any vehicle, if there is a gyroscope connected, what that gyroscope does, it does the balancing work. If there is no gyroscope, and it get misbalanced. Now, let's say suppose in my two-wheeler, if there is no gyroscope and if I bend towards one side or another side, there is chances that my scooter may get skid. But then if I connected with gyroscope, then what will happen? It will try to balance. So the timing movement when my vehicle gets bent or I get bent should be counterbalanced with gyroscope. If gyroscope is not giving response at the same time, what will happen? The scooter will get skid. Now let's see what are the difference between hard and soft real-time system. The first parameter or the first characteristics is response time. So I've told you hard real-time systems are very hard, not flexible, or very strict with timing, whereas soft real-time systems are flexible. So timing response may be missing the deadlines. Coming to the second point, that is data integrity. Now data integrity is short-term in hard real-time system, whereas they may be long-time in soft real-time systems. Now, if data integrity is more in hard real-time system, they miss the deadline and the output may be disastrous. As I've told you, again, take an example of nuclear power plant or the nuclear plant control. If the data is missed or not properly given a time, the output may be disastrous. But take an example of video conferencing, a soft real-time example. If some of the data is coming ahead of time or later of the time, it doesn't make any difference, only performance is bit degraded. The next is data files. Now in case of hard real-time systems, the data files will be smaller or medium in size, whereas in case of soft real-time systems, these files are large because more amount of data will come. Again, take an example of your missile guidance system. The data will be very less, but if I take a video conferencing system, then the data which is moving will be very high. Coming to the safety, definitely hard real times are safety critical and soft real times are not that much. Coming to redundancy type, hard real times are very active, whereas there may be a checkpoint recovery in case of soft real time system. Now take an example of database. If I'm going on updating the database and keeping one save points in between, at one moment of time, if I want to change the data, I can roll back and start the process again, which is not in case of hard real-time system. In hard real-time system, once the process is done, you cannot revert back in that case. Coming to the next, that is error detection. Now in hard real-time system, error detections are autonomous, whereas in case of soft real-time system, they are user assisted. Now take an example. I'm taking an example of flight control. If there is some error, a human cannot go and find out where there is an error. The system should find out, because if that error is not properly controlled, then what will happen? There may be an output which may take human lives or it may damage the complete system. Whereas in case of soft real-time system, user is assisted in finding out the errors. Now peak load performance, they are predictable in case of hard real-time systems, whereas they are degraded in terms of soft real-time systems. Coming to control of pace, it is environment, whereas in case of soft real-time system, it is computer. Now what this means, control of pace in terms of hard real-time system are environment. Now surrounding where the embedded hard real-time systems are used, there that control of space is there. Control of space in case of hard real-time systems are depending upon the environment, whereas in case of soft real-time systems are computer. Now take example of hard real-time system like flight control system or missile guidance system. The environment where used, it is controlling the things, whereas in case of soft real-time system, they are controlled by computer. Like an example of your online database or websites or are computer controlled. Coming to the next, there is system types. Hard real-time systems are safety critical and are hard with real time, whereas take an example of soft real-time system, there are many operating systems which will provide you soft real-time concepts. Examples of hard real-time systems are nuclear power plants, autopilot in plane, pacemaker which is fitted in the human heart. So for soft real-time system, it is mobile communication, music playing robots, weather stations and many more. Thank you.